where I would like to start is a bit further back. If you don't know the whakatauki kia mua kia muri, it literally means walking backward into the future, but it speaks to the importance of looking to our past to take learnings into the future. And I think for planetary boundaries and climate change and things like that, where we're really looking at these, huge periods of time, this is a particularly important place to start. So I want to take you back 300,000 years to when humans first evolved. If you think about human history as this rectangle on the page, you can really divide it up into two very distinct portions. There was about 290,000 years of our history that we were hunter-gatherers. And then the very recent, very short period of time, 10,000 years, where we have advanced very quickly from hunting and gathering to this modern day society that we know today. So if you're wondering what happened 10,000 years ago, that's exactly what you should be wondering. And what it was actually a change in the way that the Earth orbits around the sun. The impact of that was a massive change in global average temperatures. So this graph here that's just appeared shows you average temperatures over our history. And what you can see is that until 10,000 years ago, it was this sort of almost heartbeat looking shape. If you look at the axis, you can see the zero line here is average temperatures over the last 10,000 years. And so for most of our history, it was actually either quite a lot warmer than it is today, actually more than 1.5 degrees warmer. And then in between these warm periods, which were interglacial periods, were these long ice ages. And because it was really harsh conditions, pretty much all of our effort had to go into hunting and gathering for food. That period was called the Pleistocene, and then as you can see, when that orbit changed, actually that regular sort of heartbeat pattern changed, and we've had this really long period of much more stable temperatures than we've ever had in human history, and that period of time is called the Holocene. Now, what's really interesting is if you look at sort of human development over that time, for the first until about 85,000 years ago, all humans lived in Africa. After the last warm period, which was called the Eemian period, what happens during the warm periods is that the sea levels are much higher because there's very little ice in the poles, and so that's one of the risks at the moment. We talk about sea level rising, but the sea levels are much higher when it's warmer. As it started getting cooler after the Eemian period, the sea levels started dropping. The sea was just freezing at the North and South Pole, and the result was that the land masses, our continents, became closer and closer together. And so about 120,000 years ago, just after the Eemian period, around here, people started trying to migrate out of Africa. The first few attempts were unsuccessful, but about 85,000 years ago, there was finally the first successful migration. And these arrows sort of show the journey. So people came up through the Southern Arabian Peninsula, and actually over sort of 20,000 years ago made it all the way down to Australia. I really love this image. I find it really fascinating. Hopefully you guys do too. But what it's showing is what the land looked like then. So in yellow, you can see, the familiar land shapes that we know now, but everything that isn't white on this image was land back then. And so you can see just how much closer everything was. You could, I probably couldn't walk from Australia to New Guinea, but physically, technically you could. There was land all the way through there. And so you can see just how much easier it would have been for people to get all the way through to Australia, because those gaps across the ocean were much smaller. And so about 60,000 years ago, the first Aboriginals arrived in Australia. Through the rest of that ice age, people sort of dispersed across Europe. And then about 12,000 years ago, it warmed up. When it warmed up, of course, the sea levels rose again. And so all of a sudden, we had this, global population, but people were really separate, and we didn't have the ability to keep migrating and traveling around to see one another. So we're in these really separate spaces, which has, led to really different cultures and languages and the rest of it. But what is super interesting is that just after it warmed up, in a really tiny period, when we're talking about, these hundreds of thousand-year periods, agriculture popped up in 4 really distinct regions of the world. So the dark orange, I know it looks like 6, but in terms of the populations, it's 4 regions. And the reason that this is interesting is, nobody had cell phones. They weren't calling each other going, hey, I've just figured out how to plant carrots. What this suggests is that we had the knowledge to do that was necessary for agriculture way back in the Eemian period, and that knowledge had been handed down generation after generation for 100,000 years, just waiting for that period of time where the global conditions were conducive to agriculture, which is the Holocene. That's really fundamentally why the Holocene is so special, because agriculture meant that we could suddenly put, instead of putting all of our effort into hunting and gathering, we could, plant some seeds, know that we were going to have food later on, and put effort into advancement. And so very quickly we've gone from, quite basic settled society to this sort of pretty crazy modern day society that we have. And so, it is these, not only these repeated seasons that are important for that, but also the really extensive biodiversity that we have that's really important to the stability and functioning of the Earth system, and things like our natural carbon cycles. And there's a lot of systems in place that really help us to stay within this settled period. Now, the way that Earth orbits around the sun isn't expected to change for the next 10,000 years. So in theory, we would have another 10,000 years of this amazing Holocene period. David Attenborough calls it the Garden of Eden period. But as I'm sure most of you are aware, that's not the case. We've now moved into a space where human impacts on the planet are really contributing to changing the planet. So these graphs are the first of the sort of hockey stick graphs that became really famous in the 90s and early 2000s. But basically in the late 90s, scientists first realized that human emissions of greenhouse gases were changing the temperature on the planet at a global scale. And while it was understood for a really long time before that, from as early as the 1930s, that greenhouse gases could change the temperature, the fact that humans were having that impact became really apparent much more recently. Now, what many people aren't aware of is, once all this kind of came out as news, a lot of scientists went away and said, well, is it just emissions, and is it just climate change, and what else is happening there? I've been lucky enough to meet a few of the people, the scientists who were involved in this sort of great acceleration studies, looking at all these hockey stick graphs, and they told me the story about being in the room when they all came together to say, is it just greenhouse gases, or what else is it? And they talk about presentation after presentation after presentation showing the same pattern of rapid acceleration and impact, from greenhouse gases to ozone depletion, changes in surface temperature, changes to marine fisheries and things like that. And just this shock that it was just so ubiquitous across everything we looked at, what they were looking at. And so they brought in the social scientists, because they said, well, what can we correlate this against? Is it GDP? What is it? Population growth? But it was the same thing, it was, yes, population, yes, GDP, but also foreign direct investment, which is actually just the number of McDonald's across the world. But again, it was graph after graph. And so in this room, a guy called Paul Crutzen stood up and he said, ladies and gentlemen, I think we can safely say that we are no longer in the Holocene. We have entered the Anthropocene. So Paul Crutzen actually coined this term Anthropocene, and it was just an off-the-cuff, statement in a room to this response. But actually, the Global Geological Society have confirmed that that's true. That based on geological evidence, we're no longer in that Holocene state, the state that we know is so conducive to human development, and that we're now in a new era where human activity is going to determine the state of the planet. However, geological epochs are really long, so that doesn't necessarily mean we need to panic. At the moment, we're at this cusp of history where we will determine the state of the Anthropocene, and the goal is really that we move from the from where we are now, which is heading towards some pretty grim prospects, a hothouse Earth scenario, but we have the opportunity to guide this geological epoch so that it looks really a lot like the Holocene and is in this stable scenario.